Hello, I'm Nobby Clark. Welcome to my workshop. I'm going to start a new project on the Myford lathe, and to do this I need to remove the 3-jaw chuck. I'm very lucky with the Myford lathe. This particular model has a spindle lock. There's a little lever on the back side of the lathe here which engages in a hole in one of the pulley wheels, the large pulley wheel here. So by moving the lever across and revolving the chuck, that will engage in the hole and hold it so you can remove it. First thing obviously to do is to put a protector into the ways of the lathe, so if you were unlucky and dropped the chuck while you're removing it, you wouldn't damage the lathe's ways. So that will just drop in place. I've mounted this with a block of wood below it, so that when it's in position it can't, this part can't fall off either. So hopefully this is going to remove reasonably easily. I think it's going to get a little bit of encouragement. That's it. So we can easily remove the chuck from the lathe. It's a great thing having that spindle lock. It makes the removal of the chuck so much easier. Now when I put this on the bench behind me, I made up this little device so that any of the chucks will sit in it and can't roll off the bench. I did see somebody using items like this, I think in one of the books I was reading. This is the remains of a project I made some time ago. It was a part sort of left over, and I looked at it and thought, well, that's perfect for this particular application. So let's get this chuck out of the way. I can remove the protector. Now what I like to do first is to clean the spindle. The way I do this, because often when you're boring material, bits of swarf go down inside the spindle here and accumulate at the back. So from one of our local household shops I bought this. I'm not quite sure what it was designed for. It might be a radiator brush, I'm not absolutely sure, but it's sort of perfect for this job. It had a wooden handle on this end which I pulled off and then put some tape on it just to cover up the sharp ends of it, and I insert this through the other end of the spindle, and then that can be pulled through, and it will pull through any bits of swarf or anything that's been sitting in the spindle. Put it through again. So that should clean that out quite nicely, and I can use my Morse Taper 2 cleaning stick in here and give the Morse Taper a nice clean around. It'll be a very, very useful tool. Some bits of dirt coming off, but there's nothing really in there to worry about really. Just give the spindle a nice right round, make sure there's nothing stuck in the threads here, and it is all sort of nice and clean now. Now next stage is getting the workpiece to actually go in the spindle. Now what I'm planning on making is a Morse Taper 2 adapter to go in the tailstock to carry a centre drill. Now the easiest way to machine this is just to push it into the MT2 taper on the spindle of the lathe here, a bit of a clean up first. I bought this from an engineering supply company, and these have a hardened shaft here, but this end is unhardened and machinable. So the plan is to drill this out to take the centre drill and then cross drill it through here to put a grub screw in to lock the centre drill in place. This saves having to keep putting the centre drill into a drill chuck. I can have the drill chuck preloaded with the drill I want to use, and just swap between these two items very, very quickly. So that can be popped into the spindle there, just to knock that into position. That should lock in quite nicely. Obviously, to get this out again, I can use a drawbar through the back of the spindle here just to push this forward. What I'll do is I'll bring the camera in a little bit closer so you get a sort of better view of the actual operation here. To protect the thread on the spindle here, I've put my catch plate on here. I know for a lot of lathes that they actually do protector sleeves to go on the screw threads on spindles. I mean, I don't know whether there is one for a Myford lathe or not, and I've certainly not seen one. I have had a look around. I looked on Myford's website, but I didn't actually see one there. So it may be something, you know, perhaps in the future I could make one. Not that I have previously done any work where I've mounted a workpiece directly into the taper, but I guess having a thread protector for the spindle would be a useful thing to have. So I mean, if anyone out there knows if such a thing actually exists, a commercial made one, you know, but please let me know, because it would be a thing I would like to source. What I did do is put a dead centre in the quill of the tailstock, just so that I could bring that in, just to confirm that this centre drilling on the workpiece here is in the dead centre. I'm sure it would have had to have been for the machining operation, but I just wanted a peace of mind just to make sure that that was okay, and it does seem to be fine. Let's get that out of the way. What I did do first to get the right drill size is to experiment just with a piece of aluminium. I'm lucky in that I've got a nice set of drills from 1mm to 6mm in tenths. So I experimented. I've tried a couple of drills and found one that is a very, very nice fit. This is the centre I'm going to use, and it fits quite nicely in this test hole that I made. It's quite a nice sliding fit, so I think that's going to be absolutely fine. Anyway, what I'm going to do first is to drill a slightly smaller hole, because I believe that that will give a better guide for the correct size drill. So if I bring the drill forward, I mean, it's not got to be absolutely perfect here, but you know, what I want to do is to drill into here about 3/4 of an inch. That will give me sort of roughly to the front here, about a sort of halfway position for the centre drill to go in. So if I take that back, the quill is actually calibrated in 1/8 and 1/4 here, being an imperial lathe, so that I've got a guide here on how far to drill in. This is actually quite accurate. I mean, I've used this scale on here quite a number of times, and it works extremely well. Anyway, let's bring that in just a little bit closer. I know this is, I'm pretty sure this is probably, I don't know what material this is, whether it is made out of steel. I mean, I guess it is, but I'm going to use some cutting oil on it anyway. Right, I've already lubricated the lathe spindle here in various places it's required. So we're really all ready to go. Let's see how we get on. Seem to be clearing the chips quite happily. That seems to have gone okay with the smaller drill. I'll take the drill chuck out. Lucky also that I've got more than one chuck, so that's going to help as well. I'll get that to the right start position and bring that in. Cutting more. Right, here we go. Clearing the chips quite well, and we're almost there. Yeah, I can feel the bottom now, so that would appear to be it. move the drill chuck right out of the way. Give that a bit of a blow through. And let's try the centre in. Yep, that's going to be fine, I think. Yeah, that's going to leave me enough room here to put a cross drilling into here with a grub screw to hold that in place. That's worked out very, very well. This arbour was finished really well. It's already had the edge broken here. It's all very, very nice and smooth. I'll just clean the end of that. That's fine. Right, so the next thing to do is to use my drawbar on the back of the spindle, and hopefully this part will pop out. Excellent. No problem at all. So that's the first stage done. So the next stage, which I'll set up on the milling machine to drill a hole in here to take a suitable size grub screw, and that will be the job finished. These are perfect things for this operation. These are not terribly expensive things to buy. I did mull over the idea of actually turning a taper myself to make one of these. I know that what some people do is go to boot sales and things like that and buy old drills that have Morse tapers on the end, and then because the Morse taper part is usually not hardened, cut that part off and then convert them to use for other tools. I might still have a go at turning a metal Morse taper anyway, because I'd made my own Morse taper cleaning sticks, and that was reasonably easy to do. So I think that would be a good project to try and make one of these, because I'd like to have a couple of these for centres, because the centre I'm using here is I suppose for me a medium sized one, but I do use a slightly smaller centre drill as well, so it'd be nice to have a couple of these with different size centres in them. And for any other accessory that I want to use in it, so that may be a thing to do in the future. The next job to do is to do the cross drilling through the part so that it can be tapped to take the grub screw to hold the centre drill in position. Now, if I'd have completed the installation of my DRO system, so far I've only set up the Z movement. If I'd have set the X and Y movement up, it would have been a very easy task to mount this into the mill vise and then use an edge finder on each side of the part, and then use the half function to find the centre of the part. But I haven't done that yet, so the method I'm going to use is the method I'd used prior to having the DRO, is to mount a V block in the vise on some parallels, and then you've obviously got to find the centre position of the bottom of the V. Now the method I used to do this, I made this little pointer which will fit into the drill chuck, and it has a 45-degree angle machined on it here. So by inserting that in the drill chuck, lock that in, I can bring the chuck down and then move the wire movement until the little adapter goes exactly into the center position of the V, and then lock the wire movement into position. I can bring that out the way. Simple method, but that does the job very effectively and will give you a nice accurate center drilling position. Next stage, to mount the workpiece into the V block. Now, one problem I found was that the clamp for the V block came with the original screw. Is quite massive, and if I was trying to use that, the little knob on the end of it would clash with the drill chuck. So I searched among all the odd screws I had, and I managed to find an imperial threaded screw that fits quite nicely into here. So that's obviously not going to interfere with the chuck at all. So I can mount that onto here, drop that over the top. I've already put a little mark on here in roughly the right position that I want the thread to go. Mount that on there, and I'm putting some little copper shims under here to clamp down on. So that I don't damage the surface there of the workpiece. Put those on, and tighten that down. Those on there, and just tighten that into place. Get it in nice and tight so nothing's going to move while we're doing the drilling and tapping. Now when I bring the chuck down, it's going to clear that the head of that little screw there. Let's pop the center drill in. Whoops. There you go. Get back in there, you. There we go. Let's lock that in. Get it in nice and tight. And bring that down. And now I can move the X along to get that in the right position. Okay. Next important thing, safety glasses. And we're ready now. Very gently does it. Give myself a start position for the drill. And what I did with the chuck key comes out, and this is our tapping drill. I'm putting a 4mm grub screw into this, so this is the 3.3mm tapping drill. Slot that in nicely. Some cutting oil there, and away we go. A bit more cutting oil in. It's going to bring the drill down to the top position. It's going to zero out the Z movement on the DRO. And we're through. That was one reason why when I started installing the DRO, that I thought I would do the Z-axis first, because there's going to be a very, very useful thing to have to use immediately. And with this project coming up, I'm able to make use of the Z-axis so that I don't over drill into the hole there. What I'm going to do also is rather than tap all the way through here, when it's not a particularly deep hole, but I'm going to counter drill just a little above halfway through, so that I've only got to tap just a little over half the depth here. And there's no need to have a thread all the way through here. About half the depth of this is plenty of engagement for the grub screw to have. So there's a 4mm drill for clearance. I'm going to bring that, sorry, not the camera, so I bring that down to the top here, and I can zero out the DRO. More cutting oil on there, and we'll drill through to about 200 thousandths. That's it. That's going to give me plenty of thread for the grub screw. Pop the drill out. Turn the mill off because it's not required anymore. I'm going to use the mill chuck to hold the tap, just to get a start into the thread. Let's lock that in nice and tightly. Now for cutting medium for this. I'm going to use this strange black gloop. It's a tapping or cutting compound, and the great thing about this is that it, rather than cutting oil, which a lot of it just runs off the end of the tap, this sticks to the tap itself, and you get sort of more use out of it. Basically, we'll drop that in and start the tap in, just to get that in position. And we can release the tap. Let's hold it in quite firmly, and then use a small tap wrench to tap that through. I'll try and do that from this side so that I don't put my hands in front of the camera too much. And we'll very carefully tap through. It's always the nerve-wracking part of any operation, really, tapping holes. That is actually through now. Lovely. I've actually broken quite a few taps since I started doing this in the workshop. I suppose it's inevitable, and I suppose it happens to everyone, even the most experienced engineers. But when it happens, it's very, very annoying. Start that tap in. Just to take that. There we go. It's engaging with the bottom of the thread now. Nearly there. There we go. Take that out. Yeah. Well, a lot of the tools that I've bought for the workshop are all old second-hand ones that I've found at boot sales and car shows where they have people selling old tools, and on eBay. This is an old Eclipse tap wrench, and I've got a lot of tap wrenches and die holders, and where I can, I buy old second-hand ones because I love the older tools. You know, I mean, they sometimes show sort of signs of wear and use, but they're going to outlive me and probably whoever takes over my workshop after me as well. It's so nice to have these old tools in your hands. Well, that basically finishes that part off, so we can now quite safely remove the part from the V block. All I've got to do obviously is just a little bit of deburring. Pop that out, so now we've got we can see all the swarf and everything in there, so obviously the hole's gone through okay. What I need to do now is just to blow this through and then sort of deburr the inside of it. Bear with me just one moment. You'll hear the horrible sound of my little compressor going in a moment. It's a very noisy compressor, that. It's one I bought not long after I set up the workshop. It's actually, believe it or not, it's an airbrush compressor. I mean, somebody doing airbrushing in a studio, that must have driven them completely mad unless they put that in a cupboard. But that will now fit quite nicely in there. It's not left really any burr inside there, fortunately. That goes in, you know, the sufficient depth. I've got a grub screw ready here. It's a little bit on the long side, but that isn't really going to matter at all. And obviously I can cut the little grub screw down. So that sort of it is very long. It's engaged already with that much sticking out. So what I might do is just cut that down a bit so that I haven't got that bit sticking out. Well, as I say, it's not really going to make any difference at all. So that is the job done. Quite pleased with the result, and then using this method to set up the center position for the grub screw to go in, and it's job done very nicely. Before I wind up, I've got a confession to make. I was given for my birthday yesterday a remote microphone and receiver for my phone by my younger son, because he knows I make all the YouTube videos, and he thought this would be very useful to me. I did do a test on it and it worked fine, but I recorded all of this before and there was no sound. I'd obviously done something completely wrong and hadn't recorded any of the sound at all. So if I turn this round, that's the threaded hole I previously made. It obviously is not going to make any difference, and in fact that could be useful perhaps to have two grub screws in it to make sure this centre drill is held firmly in position. So I'm quite happy to admit when I make a mistake in doing something in the workshop and doing something like this, recording the first one completely mute. There was a lot of swearing, which obviously couldn't get picked up by the microphone. But anyway, I thought, you know, what do I do now? I don't know if it's possible to dub sound on afterwards onto the recording. I suppose it could be done, but I thought the simplest thing is to do it all over again. So I'm hoping that doing this a second time, this end of the video has been a bit more slick, if you like. But anyway, thank you very much for joining me in the workshop today, and thank you to all the subscribers to my channel. And if you haven't already subscribed, you know, perhaps you would be kind enough to subscribe, to get the old numbers up there. And thank you again for all the comments to the channel. I'm getting some comments from people all around the world now, which is really nice, and having some nice conversations with various viewers and other YouTubers. Very, very nice to be able to do that. But anyway, thanks for joining me again, and I hope to have another video for you very, very soon, with sound, of course.